This is an Ubuntu Linux laptop. This is a smart card reader that is connected to the USB port of the laptop. Now, the only thing that needs to be installed in an Ubuntu laptop to work with smart cards is the PCSD daemon, and it needs to be running as a background process. So if we type systemctl status PCSD, PC PC SCD, so you can see that the daemon is running, and this daemon is the one handling the card reader. So there's no driver for that. That is the driver. Now the next step is I launch the JC shell. So this JC shell is my own shell script that I took from a Windows setup containing the needed jars to launch a Jacob shell or JCOP. This jar was the one that we used to launch the Jacob shell from an IDE, and somehow it also works in the Linux shell. So enter, but first you have to put a card here, then enter. So you can see the light there, meaning that it's talking to the card. On the card reader is first, the card reader works with the driver, the PCSD daemon, and the card reader talks to the card through NFC. And this is how the terminal should look like. So you can see the sequence there, slash, there's a slash terminal. So all of these commands are automatically executed because I created this script. There is a jcshell.rc file where you can specify the auto commands that you should run when opening the Jacob shell. So first, in my automatic script, I set the path. This is a very important variable, path. I set the path to this one location, and I type slash terminal and slash ATR to reset the card. Now I'm going to demo here a very important thing that very difficult to understand. So you can see below that I am now typing init update. This is a built-in command of the Jacob shell, but this is also the name of the same command in the global platform GP211 specification, the init update. The init update, when let us enter this command first. No such command, so we type card, there, then type init update again. Oops, sorry, type init update again. Okay, so this is a very important error to understand. This arrow going to the right is the byte that we send to the card. We can see that by the way, this byte is always 0 in the spec. This is the length 8, and what follows 8 is a random buffer of host challenge. An important parameter here is this P1 here. By the way, 8050 is the command for init update. So whatever is the argument you pass to init update here goes into here, the P1. If we don't specify an argument here, this is automatically taken as 0. So that is why it is 0 there. Now when that is 0, it means we let the card decide to choose on the key set index, and that is why the card responded with 3 here. The card said that okay, I choose key set 3. The card choose 3, and this 02 here is just SCP-02 protocol. So, and the first 10 bytes here is the diversification data, and this first 2 bytes here, I mean the first 8 bytes, and this 8 bytes here is the card challenge, in which the first 2 bytes of that here is the in the card challenge, in the 8-byte card challenge, the first 2 bytes is the sequence counter. That also forms the card challenge as well, and the other 8 bytes is the host card cryptogram, and this 90 is the status word. The host card cryptogram is the concatenation of the host challenge and the card challenge. And see, we are not able to successfully do that in the init update here, because the init update requested let the card decide. The card chooses 3, and when the Jacob shell look into its own internal key list, it does not find a key set in the third index. That's why no such key error. The reason this is happening is because, well, first, if this had been a default card originally, this should not have been here. This shouldn't have been 3. Okay, in the default card factory default, this is FF. This is FF, and the meaning of FF is it's not in the index. The key is not in any index, but it's the default factory key, which is the value 4024F. Well-known default value, 16 bytes. For the ENC, DEC, and MAC, the same, 4024F. But once you set a key to a Java card, the mystery is that this default key is forever lost, and that new key that you set will take over. Remember that. And you can never retrieve back the original default key. So after that, you will have to specify a key set index to specify that key, because the default key is no more, gone. That is gone. Okay, so let us prove that I know the value of the key here. So let me specify it on the side of the off card. So in here I type dks3 or declare key set. This is my own command again. Well, this is just a script, but I will show you later what it does. But eventually the gist is that since the card returns 3, then we have to set a key in the third index, and this is the value of that, the decode blah blah blah. Enter. Okay, now we have a key in the third index. If we type init update again without parameters, okay, card cryptogram invalid. Okay, so the key did not match, but indeed we are now seeing a different error. The key exists, but it did not match, so the cryptogram failed to compute. So the key did not match, so now I set again a new key. This time it's Cave Babe. So it was not decode, by the way, but it's Cave Babe. There. So let's do it again. And now it matched. See? No error. And from here we can continue with the external authenticate with either MAC Inc, RMAC, or RINC bit field being set. So yeah. So okay, so one important lesson here is there is no such thing as k index 0. There's no such thing. So you cannot say k index 0. The 0 is to mean let the card made the choice. Okay, let us made the choice. For example, I will type ATR. So here I type ATR and card to reset everything. Okay, let's start. Let's specify init update 3. No such key because we lost our setting when we type slash ATR or slash card. So let us set again that key. Okay, then init update with 3. This time, instead of passing 0, we pass 3, which means we decide which key to use and the card should follow. And now it works. You can also see here that instead of 0, it's now 3. And we know that this 3 exists in the card because a while ago it was the index that the card chooses, right? There are still many index inside a card like 2, 4, 5, 6, 8. If you know the layout of the key settings inside a card, it's okay. Yeah, that's it. Thank you.